Hey, so we're starting to look at Law of Sines, Chapter 6, Lesson 1. And it says before we've been dealing with the right triangles, in this section we're going to extend our skills and look at oblique triangles, the triangles that have no right angles. And we're going to refer to these triangles the same every time. We have capital, kids have been playing, we have capital letters for our vertices. And we have lowercase letters for our side lengths. So let's get into that right here. You guys were good at geometry. We have capital C, A, B, vertices, lowercase a. Always remember, side A is opposite of vertex A. Similarly, with B and C. So side C is opposite vertex B. And it says in order to solve these oblique triangles, you need to know the measures of at least one side. Always in the law of sines, we need one side. And we need a combination of two other parts. This can be two sides, two angles, or one angle and one side. It breaks it down into the following concepts in geometry that we went over. Any two angles and a side could have been angle, angle, side, or angle, side, angle. You remember all of those. Any two sides and an angle opposite one of them was side, side, angle. Remember, we didn't say that in the reverse order. And if we have three sides, we have side, side, side. Two sides and their included angle was side, angle, side. Remember, that's different. These two are different. This angle falls between the two sides that were given. So let's take a look at page 404, the law of sines. If ABC is a triangle, sides A, B, and C, then the law of sines states this. The side A is to the sine of the angle A. That's proportional. All of these are proportional. So B is to sine B and C is to sine C. I just want to go over this quickly. The reciprocals are also true. So we could have the sine of A over A, the sine of B over B, and these are also, sorry about that, B, and the sine of C is to C. They've got to be the same. Angles on top, sides on the bottom, or sides on the bottom, all angles on the top. And all of those ratios are proportional. So that means, let's go back up here to our triangles. Phew, must have been a long break. I don't know how to use this anymore. If you guys are looking at this, Rylan and Cora, did you win your first game? I hope so. Boom, boom, boom. There we go. So, two cases for the law of sines, and we'll see this later. These are two examples of oblique triangles. This one has major obtuse angle greater than 90. And on this side, triangle ABC, on this side, no angles greater than 90. So an acute triangle. So we'll keep those terms in mind as we go through. Let's look at example 1. It says given two angles and one side. This is the exact triangle out of your book. If you guys have your books, page 405. It says for this triangle in figure 6.3, the angle C, obtuse of course, is 102.3 degrees. The angle B is 28.7 and the side B is 27.4. So you guys can see in this situation we have we have angle, angle, and the side. Now the third angle of the triangle, of course, we can find by subtracting the sum of the two from 180. That would give us 49 degrees. Now, one of the things that we want to make sure we do when we start using the law of sines is to always use the given information, not the information that we have derived ourselves. So by the law of sines, we can see, let's set up our ratios here. We have A over sine A is equal to B. Why do I keep doing that? B over sine B, which is equal to C over sine C. And so we can plug in the ratios that help us to solve this situation using B as 27.4. That is our side length. We're going to set that up. So B 27.4, and we have the angle B, so we can find the sine of 28.7. We have a ratio. What we're looking to find is all of the remaining angles and sides. So you guys just have to decide where you want to start and then go from there. So we can use this ratio to solve. This is B over sine B. We can set that equal to A, side A, over the sine of A, which we determined was 49 degrees after we did our subtraction. So solving any proportion, as you know, we are simply going to cross multiply. Well, let's just set up the ratio. So the sine of 49 times 27.4 has got to equal A times the sine of 28.7. Dividing both sides by the sine of 28.7, and then we just have some simple calculator work to finish up that problem. So let's go ahead, take a second, see what you get in doing that calculation. One quick note after doing it incorrectly, make sure you set your mode. We are in degrees, not radians. You will not get the correct answer. So for side A, doing this calculation, you should have come up with 43.06 feet. That's a good one to make sure that you've got the calculator down. So let's go ahead and continue. We have side A, so let's go 43.06, and we're looking for side C. We have all of our angles, so let's go ahead and set up that ratio. So C is to the sine of C. C we're solving for, and the sine of C, which is 102.3, and that should be equal to, one that we've used already, is the side A over the sine of angle A. So we can use that one again. So we're going to set up these cross products and quickly find out. We can just look in our book too. We've got 55.75 feet for our missing side. So we'd go up and label 55.75, 55.75, and we have completed this exercise. Go ahead and try exercise 9. 9 happens to be on page 410. And come right back here and we'll check our work. So here we go, example 9 on page 410. The first thing I wanted to do is from 180, take away the two angles that we already had, and we could see that angle A has to be 40 degrees. And now we're going to go ahead and set up. We have one side and three angles. So I'm going to say the side C over the sine of the angle C, 125. We have side C. That's why we're going to plug it in right here. Sorry about that. So the side of C is 20 compared to the sine of 125 has got to equal the side A over the sine of A. So let's go ahead and solve this one quickly. in cross multiplication, and these are in the units centimeters, you guys should get roughly 15.7 centimeters for the side A. Setting up the same situation to solve for side B, we know that B is to the sine of 15 as, let's use what we just got, 15.7 is to the, as 15.7, that's what we got for A, is to the sine of 40 degrees. And in doing that math, you should have found that the side B is approximately 6.3 centimeters. So we got our 4 angles. We calculated our missing 2 sides, and that concludes problem 9. Let's move right on to example 2. On page 405, example 2. It says a pole tilts toward the sun at 8 degrees from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the tip of the pole is 43 degrees. And of course it wants to find out the side A. We've got side A missing. We want to figure out how tall that pole is. So we've got side C, angle A. We've got, what's missing here? 8 degrees. So we've got 90 degrees plus an 8-degree lean. So we know that angle B is 98 degrees. So we can quickly calculate the remaining angle if we take 180 minus 98. 180 minus 98 minus 43. That should give us the remaining angle, 39 degrees. So angle C is 39 degrees. And of course, this time I think we're just looking for A. We're looking for the height of the pole, the length of the pole. So we set up using law of sines again. And we know that we have this value, 22, the side 22, and the ratio of the sine of 39 should be equal to the side A that we're solving for and the sine of 43. So doing that cross multiplication, we would multiply sine 43 by 22 and divide by the sine of 39, coming up with a solution of 23.84 feet. Go ahead and try exercise 41. You should find that on page 411. I won't have, yeah, I will. So once again, you guys can see some of my incredibly brilliant artwork. I did major in art in college, and that's why I'm a math teacher now. So that's good news. We have a situation, a flagpole standing on the side of a hill. The flagpole is perpendicular to the horizontal, of course, but the slope and the hill, the slope that makes a 14-degree angle with horizontal. So we have this 90 degrees plus 104. We have a 104-degree angle here. We have a 20-degree angle from the bottom, it says, from the shadow end to the tip of the sun. We have a 20-degree angle. So 124 from 180, do that quick, that'd be 56 degrees, 56 up here. So we're going to set up our ratio. We are looking for, we want the equation, then we want to find the flight of the flagpole, of course. So if that's side A, that's angle A. If this is side B, this is angle B. And this is angle C, so that's side C. So we're looking for side A. We're going to go ahead and set up this ratio. A is to the sine of 20